let's go ahead and take a look at problem 6.1.18. We have a probability distribution here on the right side. Here the random variable represents the number of marriages an individual has had, and the likelihood of that individual, or again a random selected person, would have that number of marriages. And so you can see this 1 here represents that the probability, if you randomly select a person, that they've been married one time would be 0.576, or 57.6% of the time. And so this is a probability distribution because, one, it's showing you a table of values that shows you the likelihood of these events here, and that again is the number of marriages an individual has. That's what X represents. And again, the sum of this equals to 1. If you want to verify that, you could do that. All the probabilities are between 0 and 1. And so that's a probability distribution. Next, I want to show you using StatCrunch how you could look at what the distribution is and how to calculate the expected value, or what we call the mean of the random variable. And we use the term expected value because we're talking about a probability distribution. So we want to look at what is the likelihood, what would we expect to see, right? And so once you open the data in StatCrunch, you would go to Stat Calculators. In this case, we'll use the custom calculator. The variables is X. The values, or the weights, the probabilities, are in P of X. And then we hit compute. Once you hit compute, you can see you have a distribution. And it's a calculator we can use to actually calculate probabilities, which I'll show you in a little bit. And so looking at this, though, you can then see which distribution that would be. You'd pick the correct one. It looks similar to the one we had graphed already. Then the next question comes out, what's the distribution? Has one mode skewed to the right? We can get that from the distribution. Compute and interpret the mean of the random variable. And so back to what we were looking at there, you could see the mean is 0.907. So again, where it gets a little bit kind of abstract is this idea that what would we expect? What is the interpretation of this value? 0.9097. That means that the average person, or the number of marriages we expect a randomly selected person to have, is 0.907. And it's close to 1, so we would say you'd expect a value of 1. But again, in this case, it's 0.907. And then the next question, again, there's the interpretation of it. If many individuals were surveyed, one would expect the mean number of marriage to be the mean of the random variable, which is 0.907. The standard deviation is computed here. You can see I get 0.744 or 0.745 or 0.7 if we go to 1 decimal place. And then we can answer excuse me, random probability questions here. What is the probability the randomly selected individual was involved in 2 marriages? And you get the answer right there, 0.111. Your custom calculator could also do that. I could put that to an equals, put 2 in here, compute, and you get your 0.111. The next question is, what's the probability was involved in at least 2 marriages? So that's 2 or more. So you would add up all of these values, or on your custom calculator, you do greater than or equal to 2, and you get 0.145 is what we get right here. So that's how you would use the custom calculator for those probability distributions, means, expected values, and standard deviations.